reevaluate the project objectives. Because it turns out that some things can't be predicted, and coin flips being the canonical example, you can't predict a coin flip no matter how good your model is, right? And so if you at the end of it decided that what you're trying to achieve is not predictable, you might have to go back and rethink what you're trying to achieve. The final step, which we're not going to focus on a lot in this class, but is one that's actually really important, and often where this process goes wrong, is deployment. So you can have a model that is statistically valid and economically meaningful for whatever project, whatever objective you're trying to achieve, but you've got to get this into the hands of somebody else to use it, right? It's either got to be deployed as a decision-making tool, or it's got to make its way into a final product, or it's got to be used somewhere. And in this process, you're going to have to work with typically the DevOps side of the organization to build some kind of process to get it into the hands of the final users. You're going to have to work with management, where oftentimes management doesn't understand this technical process that led to this model creation, and may have a hard time evaluating its usefulness. So there's a part of deployment that's about communication, and so you've got to overcome a number of hurdles to actually get the model, to where it's providing value. And if you survey companies that deploy data science extensively, the general number that's thrown around is that roughly 90% of machine learning models that make it to kind of this stage of the process don't actually get deployed. So again, this last step of deployment is a big hurdle that is not a guarantee to go through. But even after the model's deployed, you're continuously reevaluating. You're continuously going back and seeing if the model continues to satisfy the project objectives, see if you think that the data generation process has changed or the world itself has changed to make the data change. You're retraining your models, you're rebuilding them, improving them, and going through this process again and again. So as we go through the class, every case is going to follow roughly this process. Say for our first case, which is a little more of an introduction, but otherwise we're going to basically follow this process as we go through. We're not going to always neatly delineate every step that we're in, but as you think about how you're going through and working on the case, this is the process you want to have in mind. Questions before we move on? All right. So just to give a little bit of a positioning for this course, so I'm going to use the term data science and data mining interchangeably because as far as I'm concerned, there isn't much of a difference in the way they're often used. So I've already been switching back and forth between these terms and these introduction slides. But just so you know, the objective is to provide kind of hands-on experience, thinking like a data scientist. The goal is to understand the challenges and opportunities that data mining provides. And again, this is intended to be a very practical class. So we're working with cases, which you've seen cases from other Darden faculty. We have a textbook, but the main focus of this class is going to be, we've got a case, we've got a data set, we've got some techniques that we're going to read about. Can we apply them to this particular real-world case and real-world data set? The expectations for this class is that you guys come prepared for case discussions and in-class competitions, which we're going to have a couple of those. You'll have some, as part of the in-class competitions, you'll be presenting the work that you've done, and as the final deliverable for this class, you'll deliver a presentation on a data science project that you guys have been working on. And the expectation is that you come ready to deliver high-quality presentations about the work that you've done. So this isn't generally considered an easy class. There's a lot of work involved. I'll say that. But I do want to say that I understand that in this program. Not everybody has most people do not have software engineering backgrounds, and that's not the expectation. While the material is technical, and kind of its parts of it, there's a lot that goes into a data science project, and I expect people to contribute in multiple ways. So if you look back at this process, the real programming steps are like right here, right? 2 steps in the middle of this process. But the business understanding, the data understanding, a lot of that's done using data visualization or understanding the industry background, things like that. And so I expect that you guys also contribute, not just I can figure out how to implement what I want to do in Python, but also you contribute to the discussion by providing some of the other parts of the process that are maybe less technical, but no less important. So we're going to be storing, wrangling, and understanding data. We're going to spend a lot of time on visual analytics. We're going to be prototyping models. We will build solutions and predictions and try to validate these. And then we're going to be conveying these insights to others. Some of the technologies we'll be using are on the right. You will work on virtual machines on Amazon Web Services via a platform, an open source platform that I maintain and deployed called Jupyter Hub. So I understand that probably some of you guys have installed local Python environments on your own computers, and you're comfortable working in those environments. You're welcome to try to do that, but I prefer that students use the cloud computing platform for a couple of reasons. First, I do not provide any technical support for a Python environment on your own laptop. I will, by the end of class, give you guys instructions for how to replicate the Python environment we have in the cloud on your own personal machines. So you'll have something to take away, and you can still continue to run the code. You can download it and run all the code on your own laptops. But I found that, especially as we're getting going, it's just too much trouble for everybody to try to. The phrase I like to use is there are ghosts in the machine. It turns out that you can easily, even following instructions exactly, because one person's computer is a little bit different and you've installed something in the past, things can collide and there can be weird bugs that crop up. And I don't want that to get in the way of learning. So on AWS, I can control the environment. Everybody's working from the same computing environment. They have the same set of resources, same set of packages. I know that it's all going to work. And I can also distribute large data sets there, and you don't have to worry about downloading 8 gigabytes of data to your own local computer. But by the end of class, you will have access to the resources you need to run it locally. So you won't. This isn't something that's going to go away at the end of. You can't access the material after class. But that's how we'll work with it throughout class.
So
yeah, Brian.
Does this mean in order to access data sets, we're going to need internet connection, so we can't do this off Wi-Fi?
Yeah, you will need, because we're working in the cloud, you'll be working through a browser. You will need to have a connection to the internet. Yeah. Like I said, if you want to go through yourself and try to install Python and download, and you can download the material to your own local computer and work on it, but I don't provide any support for that. We're going to use Tableau for data visualization. We're going to code in Python, and we're going to compete on category competitions. So you're going to receive starter code for each of the cases that is intended to be like a tutorial and like a quasi problem set as you work through the case that will help get you in the right direction, so you're not starting from scratch, and kind of help guide you to the main decision points as you're working through the case. We're going to be all of our cases are going to be within a particular domain. So as we go through the cases, you'll have some exposure to applying data mining techniques in particular domains. Marketing, operations, finance, strategy, and general management. You'll present your visualizations, models, and insights to your peers. So just to give a little bit of philosophy of, because I know that, I think by this point in the program, generally you guys have seen R. Is that correct?
Yes.
Yeah. So, but Python is not something that has come up in this program yet, right?
Correct.
So this is, I want to talk a little bit about my philosophy to kind of teaching programming in Python, which is really one of immersion. So you will have, you'll get these pieces of starter code, and you're intended to work with them without a lot of like kind of formal training in Python, and they're intended to, even if you don't have any formal training in any programming languages at all. Their goal is to, the code will have explanatory text around it, and your goal is to learn to read it, and through modifying the code and going through the cases, learning to speak it as well, right? This is intended to be an immersion kind of experience if you kind of map it to a traditional language learning process. You're going to be working in teams, and so hopefully every team will have some people that have more comfort with programming languages than others, and hopefully you'll be able to learn from each other. And then there will be 5 exercises, basically from first one's going to be due on Wednesday, all the way through till we meet again in January. They'll be due about on a weekly cadence with a break there over Christmas and New Year's, which are intended to be little tutorials for various aspects of programming throughout the class. So if you know Python, especially Python for data science, they should be very straightforward.